We're going to take a look at some more exponential equations and see how we can solve them using logarithms. So let's take a look at an equation that you've solved already. 2 to the x equals 32. This is an exponential equation, so our variable here is in the exponent. And we can solve this by finding a common base. So here we have a common base. So we know that x must be equal to 5. But what if we change that equation slightly and we're looking at 2 to the x equals 33? 33 is not a power of 2, so we need to use a method other than looking for a common base. Now, lucky for us, we just learned about logarithms, and what we can do with this equation is take the log of both sides. Now, we can use any base that we want. It would be convenient to use the common log, which is what I used here, or the natural log, because those buttons appear on our calculators. Now, we learned of a property that said that if we've got an exponent, that we can make it a coefficient. So we're going to bring this x over in front here, so that we have x log of 2 equals log of 33. So to solve for x, we just divide both sides by log of 2. This will cancel, and we get x equals log of 33 over log of 2. And if you type that in your calculator, you're going to get that this is approximately 5.044, which makes sense. If 2 to the 5 is 32, then 2 to 5.044 should be close to 33. Now I want to show you something else here. Let's call this method 1. We're going to look at a second possibility. That's instead of taking the common log, we can take the natural log. So that would look like this. We'd have ln of 2 to the x equals ln of 33. Now we can use that same property and bring that x to the front. So we've got x ln 2 equals ln 33. Divide both sides. And we end up with x equals ln of 33 over ln of 2. And if you put that in your calculator, you're going to get approximately 5.044. Now you see these two expressions here, log of 33 over log of 2, is equal to the natural log of 33 over the natural log of 2 because of that change of base formula that we learned in one of the previous videos. So it really doesn't matter what base you choose from the beginning, but you want to keep in mind that it's most convenient to use either the common log here or the natural log. So let's look at one more equation like this. We're going to make it a little more complicated. Let's have 3 to the 2x plus 5 equals 71. So this is still exponential. Our variable is in the exponent. And we solve this the same way we would solve a linear equation. We're going to first isolate as much as we can. So we can get rid of that 5. We've got 3 to the 2x equals 66. And now we need to get this out of the exponent. So we'll take the log of both sides. You can use your common log. I'm going to use the natural log. And we will get the same exact answer. We can bring that 2x in front. And now we want to isolate the x, so let's get rid of a 2 and an ln 3. So this is gone, and we are left with x equals ln 66 over 2 ln 3. and that's approximately 1.906. Now let's do one where we change the base a little bit, and instead of 2 or 3 or 5, let's play with the idea of e to the x being equal to some number. Now this would work the very same way. We can take the common log of both sides. We get x log e equals log of 7. So x is log of 7 over log of e. And this is approximately 1.945. Now here I want to show you an alternative. So this is method 1, this is method 2. We've got e to the x equals 7. Instead of using the common log, if we use the natural log, take the ln of both sides. Notice what we have here. We've got the ln of e to the x, which we know is just equal to x. We get x equals ln of 7. And if you put that in your calculator, you will get 1.945. Same answer, a little bit less work. So let's make that problem a little more interesting. Now here, we're solving for x, so you use your techniques to isolate the variable as much as you can. We're going to divide both sides by 4. We get e to the 2x equals 3 over 2. So now we'd like to get this variable out of the exponent. So let's take the natural log of both sides. Now you can take the common log, but you're going to have a few more steps than those of us who just use the natural log. So here, on the left side, we're going to just be left with the exponent. 2x equals ln of 3 over 2. Divide both sides by 2. See, that's going to be about 0.202. Okay, we'll take a look at one more equation and then we'll move on to your summary. Let's say we had something like this. Now this is actually in quadratic form, so we can factor this. First I'm looking at this -3 and the 2. In order to get that, we would need a -2 and a -1. The product of these two numbers will give us the +2, and the sum will give us the -3. But we need something times something to be equal to e to the 2x. Well, that would just be e to the x. So remember, when you multiply, you add exponents. So e to the x times e to the x would be e to the x plus x, or 2x. So now we set each of these equal to 0. We isolate, we get e to the x equals 2 and e to the x equals 1. Now we'll take the natural log of both sides. You can take the common log if you'd like, but you're going to have a little more work. So here on the left, we're going to have x equals ln of 2. And on the right, we're going to get x equals ln of 1. And you might remember from a previous video that the ln of 1 is actually equal to 0. But we need our calculator for the approximate value of ln 2, which is 0.693. So here's our summary. If you are solving exponential equations, that's equations that have their variable in the exponent, first you look for a common base. If you don't have a common base, you want to take the log of both sides. Now you can use the common log or the natural log. The natural log is most convenient when you have an equation involving e to the x.